Two friends own a craft business making placemats and table runners. It takes 1 hour to make one placemat and a half hour to make one table runner. Combined, they will only spend 16 hours a day working. Only 20 items will be made per day. Create two inequalities and graph the inequalities and indicate the intersection of two lines of the graph. All right, so what I see here is the variables. I'm going to put P for placemats, T for table runners. Now this is a classic systems of inequalities. Inequality 1 is 1 hour per placemat plus 1/2 hour per table runner is less than or equal to 16. Inequality number 2, I have the amount of placemats plus the amount of table runners is less than or equal to 20.
Now, slope-intercept form is y is equal to mx plus b, where the b is my y-intercept and the m is my slope, which is rise over run. If it's a positive slope, I go up. If it's a negative slope, I go down. But I always run to my right. Now let's change these inequalities and put them into slope-intercept form. I do this because I want to isolate the p. I subtract half t from either side. So I have p is less than or equal to negative 1/2 t plus 16. Now we're going to graph this here in a minute, but I want to look here. My slope is negative 1/2 and my y-intercept is 16. Now on our second inequality, I want to isolate the p. So there's really 1t here, and I'm going to subtract 1t from either side of the inequality. P is less than or equal to negative 1t plus 20. My slope, or m, is negative 1, and my y-intercept is 20. To graph this inequality, I'm going to start by plotting my b. That's my y-intercept, right here at 16. Now my slope says go down 1 over 2. Down 1 over 2. And basically, it's going to make a line. Goes from here to here at 32. Now, since it's less than or equal to, I would shade below the line. My second inequality, I plot my first point at the B. Now my slope is negative, so I go down 1 over 1. Down 1 over 1. And basically here it's going to look something like this. Now, the shaded region is the solution to this system of inequalities. We've created the two inequalities. This is a system of inequalities. We've graphed our graph, and now we have to indicate the point of intersection. Well, right here, the point of intersection, the t is equal to 8, and the p is 12. One way we could solve this mathematically, since they're equal here, we could use elimination. And what I mean here is I'm going to subtract the equations. P minus p is 0. 1t minus half a t is half a t. 20 take away 16 is 4. Now half times t is equal to 4. To solve this, we do the opposite. Opposite of timesing by a half is timesing by 2. I do this to both sides. I find t is equal to 8. To solve for p, I just replace the t in this equation with 8. To solve this, I subtract 8 from each side, and p is equal to 12.